NEC Section 680.26 requires all metal parts, including electrical equipment, that are not isolated from the pool water to be grounded in accordance with NEC Section 250. NEC Section 250.118 specifies the grounding electrode requirements for swimming pools, including bonding to the grounding electrode system. NEC does not specifically address the grounding and bonding of temporary fixtures in indoor swimming pools or natatoriums. However, industry best practices and local codes may require such fixtures to be grounded for safety reasons. Ground all metal components of temporary fixtures such as bleachers, guard stands, and movable ladders. Connect the grounding conductor to the permanent grounding system of the pool. Ensure that all grounding connections are securely made and protected from damage. Local building codes and ordinances may have specific requirements for grounding and bonding indoor swimming pools. Consult with a licensed electrician or qualified electrical inspector for guidance and to ensure compliance with all applicable codes. Regular inspection and maintenance of all grounding and bonding systems is essential for electrical safety. The purpose of grounding and bonding is to create a low impedance path for fault current to return to the source, which allows overcurrent protective devices to operate and clear the fault quickly. This minimizes the risk of electric shock and fire. Grounding refers to connecting non-current carrying metal parts of an electrical system to the earth. This provides a reference point for voltage and helps to stabilize the electrical system. Bonding refers to connecting all metal parts of an electrical system together to create an electrically continuous path. This ensures that all metal parts are at the same potential, which reduces the risk of electric shock. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrode system should be connected to the building's main grounding busbar. The bonding system typically consists of bonding jumpers that connect all metal parts of the electrical system together, such as metal conduits, metal enclosures, and metal equipment. The bonding jumpers should be sized according to NEC Table 250.102 cone. The grounding and bonding system should be inspected regularly to ensure that it is in good condition. All connections should be tight and free of corrosion. Any damaged or missing component should be replaced immediately. It is important to consult with a licensed electrician or qualified electrical inspector to ensure that the grounding and bonding system is installed and maintained in accordance with all applicable codes. When considering grounding and bonding for swimming pools, it's crucial to understand equipotential bonding. Equipotential bonding aims to minimize voltage gradients in and around the pool area. This is achieved by connecting all metallic parts, such as the pool reinforcing steel, metal fittings, and nearby metallic structures, to a common bonding grid. This grid is then connected to the electrical grounding system. The goal is to ensure that if a fault occurs, the voltage difference between any 2 points accessible to a person in or around a pool is minimized, thereby reducing the risk of electric shock. The NEC provides specific requirements for equipotential bonding in Article 680. Grounding typically involves connecting the electrical system to the earth, while bonding involves connecting all metallic parts together to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety in swimming pools. In addition to the NEC, local codes and regulations may also apply to swimming pool electrical installations. It is important to check with the local authorities to ensure compliance with all applicable codes. Remember that electricity and water can be a dangerous combination. It is important to take all necessary precautions to prevent electric shock. Regular inspections and maintenance of the electrical system are essential for safety. If you are not qualified to work on electrical systems, it is important to hire a licensed electrician. Here are some additional considerations for grounding and bonding indoor swimming pools. Firstly, the size of the grounding and bonding conductor should be sized according to the NEC. Secondly, the grounding and bonding conductor should be protected from physical damage. Thirdly, the grounding and bonding connection should be accessible for inspection and maintenance. Fourthly, the grounding and bonding system should be tested periodically to ensure that it is functioning properly. Fifthly, all electrical equipment installed in the pool area should be listed for wet locations. Sixthly, ground fault circuit interrupter protection should be provided for all electrical circuits serving the pool area. Seventhly, signage should be posted to warn people about the dangers of electricity and water. Eighthly, emergency shut-off switches should be provided to disconnect power to the pool in the event of an emergency. Ninthly, pool covers should be properly grounded and bonded. Tenthly, underwater lighting should be installed in accordance with NEC requirements. By following these guidelines, you can help to ensure the safety of people using indoor swimming pools. In the context of temporary fixtures, the application of grounding and bonding principles requires careful consideration. While the NEC doesn't explicitly mandate grounding for all temporary fixtures, the intent of electrical safety regulations should guide the decision. Temporary fixtures, such as bleachers, lifeguard stands, and portable equipment, can introduce potential hazards if not properly grounded. If these fixtures are made of metal or have metal components, they can become energized in the event of a fault, posing a risk of electric shock. Grounding these temporary fixtures can provide a path for fault current to flow back to the source, tripping the overcurrent protective device and energizing the fixture. This helps to minimize the risk of electric shock. The method of grounding temporary fixtures may vary depending on the specific application. One approach is to use a grounding cord with a grounding pin that can be plugged into a grounded outlet. Another approach is to connect the fixture to the building's grounding system using a grounding conductor. The grounding conductor should be sized according to the NEC and should be securely connected to the fixture and the grounding system. In addition to grounding, bonding may also be necessary for temporary fixtures. Bonding involves connecting all metal parts of the fixture together to create an electrically continuous path. This helps to ensure that all metal parts are at the same potential, which reduces the risk of electric shock. The bonding connection should be made using bonding jumpers that are sized according to the NEC. It is important to note that the grounding and bonding of temporary fixtures should be performed by a qualified electrician. The electrician should be familiar with the NEC and other applicable codes and standards. The electrician should also inspect the temporary fixtures regularly to ensure that they are properly grounded and bonded. The importance of regular inspection and maintenance of grounding and bonding systems cannot be overstated. Over time, grounding and bonding connections can corrode or become loose, which can compromise the effectiveness of the system. Regular inspections can help to identify and correct these problems before they become a safety hazard. The inspection should include a visual examination of all grounding and bonding connections. The connections should be checked for tightness and corrosion. Any damaged or missing component should be replaced immediately. The grounding system should also be tested periodically to ensure that it is functioning properly. The test should be performed by a qualified electrician using calibrated test equipment. The test results should be documented and kept on file. In addition to regular inspections, maintenance should also be performed on the grounding and bonding system. Maintenance should include cleaning and tightening all connections. Any corroded or damaged component should be replaced. The grounding electrodes should also be checked to ensure that they are in good condition. The importance of consulting with a licensed electrician or qualified electrical inspector cannot be overstated. A qualified electrician has the knowledge and experience to properly install and maintain grounding and bonding systems. An electrical inspector can ensure that the installation meets all applicable codes and standards. Consulting with a qualified professional can help to ensure the safety of people using indoor swimming pools. Remember that electricity and water can be a dangerous combination. It is important to take all necessary precautions to prevent electric shock. Regular inspections and maintenance of the electrical system are essential for safety. If you are not qualified to work on electrical systems, it is important to hire a licensed electrician. Grounding and bonding are critical for electrical safety in indoor swimming pools. Understanding and adhering to NEC requirements, industry best practices, and local codes is essential to protect people from electric shock hazards. The key elements include proper grounding of permanent fixtures, careful consideration of temporary fixtures, equipotential bonding, regular inspection and maintenance, and consultation with qualified professionals. By following these guidelines, you can create a safe environment for swimmers and staff alike.